بسم الله الرحمن الرحيم. أبنائي وبناتي طلاب الصف الأول الثانوي، بنكمل مع بعض حل أسئلة كتاب المعاصر page 216. السؤال 34. The opposite figure shows a car moving with uniform acceleration A to cover a displacement D over a time interval T if the velocity of the car at the end of this interval is V final. So, which of the following relations is correct? As you notice from the choice that all of them speaks about the displacement, and if we discuss the law to get the displacement, D equals V initial T plus half A T square. As you see, there is no V initial here in all choices. So let's try to solve this problem. At the beginning, you know well that D equals V initial T plus half A T square. And also V final equals V initial plus AT. As you see, we don't have in the choices here V initial. So let's use V initial from this law here. V initial equals V final minus AT. I took AT on the other side. So V initial equal V final minus AT. We use this law here. Okay, so D equals, instead of V initial, V final minus AT times T plus half AT square. So D equals V final T minus AT square. We multiply T here and T there, okay? Plus half AT square. So D equals V final T minus AT square plus half AT square means minus half AT square. You have here minus plus half AT square minus AT square. So we have minus AT square. This answer found here in choice C as you watch. Okay, guys? So we finished 34. Let's move to 35. A vehicle, a car, started motion from rest, so V initial equals 0, with a uniform acceleration of 2 meters per second square. So this is A. For 6 seconds T. And it moved at a uniform velocity for half minute. So let's get the V final, and the object will move with V final as uniform velocity for half of minute. Next to that, the brakes were applied to decelerate the vehicle to stop within 5 seconds. Then the greatest velocity reached by the vehicle equals. Let's solve it together. At the beginning, as you see, V initial equals 0 and A equals 2 meters per second square for times 6 seconds. Okay, so we can get V final. V final equals V initial plus AT. V initial 0 plus 2 times 6 equals 12 meters per second. Okay, and let's calculate the distance. Let's call it D1. D1 V initial T plus half AT square. So V initial 0 times T 0 plus half. The acceleration is 2 times 6 square. 36 times 2 or 36 meters. Okay, what comes next? The object will move with this velocity 12 meters per second as uniform velocity for half minute for 60 seconds. 30 seconds. So the second distance equal v times t because it is uniform velocity. So 12 meter per second times 30 seconds equals 360, right, meter. What comes next? Next to that, the brakes were applied to decelerate the vehicle to stop. So now we have V initial is 12 meter per second, the same velocity. V final equals 0 meter per second to stop in 5 seconds. In 5 seconds, t equal 5 seconds. So we can calculate from here the acceleration. V final minus V initial over t. 0 minus 12 over 5 seconds. So 12 over 5, 2.4. 2.4, hold on. So acceleration equal negative 2.4 meter per second square. We got the acceleration, so let's calculate the distance. We call it d3 because I found here in the second equation the total distance. So we need to calculate the distance v initial t plus half a t square. So v initial here is 12 times 5 plus half times the acceleration here negative 2.4 times t square means 5 square. So here is 60 minus 25 times 1.2. 25 times 1.2 means 30, right? So 30 meters. So at the beginning, as you see, he needs the greatest velocity reached by the vehicle, the 12 meter per second. Okay, this is the first question. The second, the total distance, we need to calculate all this distance, d1, d2, d3. d1, 36. d2, 360. d3, 30. So the total distance 6. 3 plus 3, 12. So the total displacement or distance 426 meters. So we answered it. The greatest velocity 12 and the total distance 426. Let's go to number 36. A car was moving with uniform acceleration in a straight line if the velocity at a certain moment was 30 meters per second. And after 5 seconds from this moment, the velocity become 10 meters per second. So this is V initial and this is V final. And we have the time, so we can get the acceleration, the uniform acceleration. Then the distance covered through the 30 second only of this interval. What if we can calculate the acceleration? We will get the acceleration so easy. And we get the distance covered by after 2 seconds. And the distance covered after 3 seconds and get the difference. So we will know the distance covered through the 30 second only. Let's try to solve it. At the beginning, you have V initial equal 30 meter per second, V final equal 10 meter per second. So as you see, the acceleration will be negative, right? Negative acceleration, 5 seconds. So A equal V final minus V initial over T equals 10 minus 30 over 5 means negative 20 over 5 mean negative 4 meter per second square, right? What else? Let's calculate the distance after 2 seconds, after t equal 2 seconds. So V initial t plus half AT square. V initial here we have 30 times 2 plus half times negative 4 times 2 square equals 60 minus here 4 times minus 2 minus 8 means 52 meters. This distance covered after 2 seconds. Let's calculate d after 3 seconds. So V initial 30 times 3 plus half the acceleration negative 4 times 3 square. So 90 here 90 minus 18. It equals 72 meters. So the difference equals 72 minus 52 equals 20 meters. So the object moved or covered the distance 20 meters in the third second. Okay, we have the answer. Yes, we have the answer. Let's move to 37. Here a car has started its motion from rest. V initial equals 0. With uniform acceleration, we have the acceleration. After moving a distance, we have the distance. The driver turned the engine off, so the car stopped. 5 seconds afterward, then the acceleration of the car during the last 5 seconds. To calculate it, we need to calculate the final velocity here at the beginning, right? Let's do it bit by bit, step by step. What do we have? We have V initial equals 0. The acceleration A equals 2 meters per second square. The distance equals 100 meters. So it is easy to get the final velocity here. V final square equal V initial square plus 2AD. So V final square equals 0 plus 2 times the acceleration, 2 times the distance, 100. So V final square equal 400. So V final equals 2 meters per second. Right, guys? What else? We can calculate the acceleration, right? He needs acceleration of the car during the last 5 seconds. So the last 5 seconds makes this as V initial, and now V final equals 0. The second part of motion through 5 seconds. T equal 5. So the acceleration now, it is negative acceleration, right? V final minus V initial over T. V final 0. Because he said stopped after 5 seconds. Minus 20 over 5 means negative 4 meters per second square. So we calculated the acceleration of the car during the last 5 seconds. It is negative 4. What else? He needs the distance covered during the last 5 seconds. So D equal V initial T plus half AT square. D equals V initial 20 times 5 plus half the acceleration we calculated for negative 4, 5 square. So 100 minus 2 times 25, 50 means 50 meters. Okay, guys? So he gives me the problem in 2 parts. We can get from the first part the V final, and it is V initial for the second part of motion. Got it? So the answer negative 4 meters per second square and 50 meters. Negative 4 meters per second square and 50 meters. Let's move to the last problem in this. Number 38. 2 cars A and B start their motion from rest. So V initial for both equals 0. in straight lines from the same point at the same instant. في نفس اللحظة. If car A moves with acceleration A and car B moves with acceleration 1.5 A, so that after 50 seconds, بعد 50 ثانية, the velocity of the car B becomes larger than the velocity of car A by 50 meters per second. Then he needs the acceleration A and the difference between the covered distance by the two cars A and B. Let's get some information from the problem. At the beginning, we have two cars A and B. Both have V initial equals 0. V initial equals 0. And the time for both 50 seconds. T equal 50 seconds. And here the acceleration A and here 1.5 A. So let's calculate VA final equal VA initial plus A for AT, right? VA final equals 0 plus A times T, so A times 50 means 50A. VB final equals 0 plus 1.5 A times 50, right? So 75A. Right, guys? He said, which one is larger? B, right? Let's read it. So that after 50 seconds, the velocity of car B becomes larger than the velocity of car A. So VB final minus VA final equals 50 meters per second. So VB 75A minus 50A equals 50 from here, right? So 25A equals 50. Divide by 25, divide by 25. So we got A equal 2 meters per second square. We got A. So the acceleration, as you see, 2 meters per second square. What he needs? The difference between the covered distance by the two cars A and B. So let's calculate the distance for both. dA equal V initial T 0, right? Plus half the acceleration for A is, the acceleration for car A is A, means times 2, times the time square, 50 square. This is equal 2,500 meters. For the distance for B, V initial T, you know V initial is 0, plus half the acceleration of B, we got it 1.5A, and A equal 2. So 1.5, the acceleration 2 times T square, 50 square. 2 times 1.5, 3. Divided by 2, 1.5 times 50 square equals 3,750 meters. So the difference between the distance for both cars, 3,750 minus 2,500 equals 1,250 meters. So we finished it. So we got the acceleration is 2, and the difference between the covered distance 1,250. I hope you understand that. Now we finished page 216. كان معاك مستر إبراهيم سلطان فيزيكس اند كيمستري تيتشر. رجاء المتابعة ونشر الفيديوهات دي لزمايلك عشان الكل يستفيد. ربي يوفقكم انتم واولادي.